This is a continuation of the study guide for solutions for the study guide for Algebra A, Test 2, Quarter 4. So let's take a look at problem number 16 here on the study guide. It asks us to graph the system of inequalities. And so this is a inequality that's set up for the slope-intercept form. So our y-intercept's positive 2. So we're going to go up 2 spaces on the y-axis. Put a dot there. So again, this is our y-intercept. The slope is 1 to 1. So if you don't see a number out in front of x, it's just 1. And you can write that as a fraction. The rise over the run as 1 to 1. So notice I'm going up and then to the right each time. That shows the slope. Slope is a constant change of the x and y values for the line. And so we go ahead and graph some of these points. Again, I'm just going down to the left or up to the right. Now notice it doesn't have a line underneath the inequality sign. So that means we have a dashed line. The dashed line represents the solutions are not on the line, but the solutions are on one of the sides of the line. So how do you figure it out? Well, it says the y values need to be bigger than the expression. The bigger y values are above this line because this is the direction for bigger y values. Look at the next one. Positive 1 is the y-intercept. So you're just going to go up 1 space. And then the slope is negative 2 to 1. So down 2, right 1 is one way to do it. Down 2, right 1, down 2, right 1. Or we could go the other way. We could go up 2, left 1. Gets you on that same exact line. Now, what kind of line? Well, this time it's a solid line. Notice how it has the line underneath. That means equal. So you draw that solid line, and it says y is less than or equal to. Less y's are below. Below because that's the direction of smaller y's. So where do you shade? Where are the solutions? They're where the two lines agree, which would be right in this region here. Well, look at our next one. We've got a positive 3 for the y-intercept, so up 3 spaces, and then use the slope, negative 1 to 1. So down to the right, down to the right, down to the right. And so do that a few times until you can draw a nice line. And then we can also go up to the left, up to the left, up to the left. And that gets us on that same line. Now what kind of line? Well, it's a dashed again. The reason is it doesn't have that line underneath the radical sign. So notice how there's no line underneath that radical sign. But which way would I shade? Well, follow what the inequality says. Y's less. The lesser y's are below the line because that's the direction that you go to find smaller y's. The next one says negative 1 for the y-intercept. So go down 1 space from the origin, and the slope is 1 to 2. So up 1 over 2. Up 1 over 2 to the right. And then we could also go down to the left a couple spaces, and so we also have that as our points where the lines end up crossing. And so from that point we look and see what kind of line we should be drawing, and it shows the line underneath, so it's another solid line. The lines on the points on that line are solutions. So go ahead and draw that in there. And now we figure out the shading. So it says positive y is less, or greater this time, sorry, greater. So greater means above. And so which way do we shade? Well, look where they agree. Off to the left again, right in this region. Well, the next type of problem is a ticket problem. So we have a movie tickets are sold at $4 for adults, $2.50 for students. So let's set up our equation. So we're going to have A plus, let's go with C for students because S might look like a 5, equals the total number of tickets sold, so 390. So there were adults, 390 adults and students all together. Now, they sold at $1,410, and this would equal our value equation. The value of the adult ticket, $4, so times the number of adults. And then the value of the student ticket, $2.50 times the number of students, C. So notice how you have your quantity and your value equation. So what you're going to do from this point is multiply by some number to cancel out one of these unknowns. And what are they asking for? How many student tickets were sold? So we want to keep the students. We want to cancel out the adults. Let's multiply by negative 4. So again, notice that what they're asking, how many student tickets? That's what they want to find out. So we have negative 4a minus 4c equals, and then this makes a negative, it looks like 1560 is what you get. And so we go ahead and add these together, And when we do so, we end up canceling out the a's, and over here we have a 1.5, negative 1.5c equals, and this makes a negative 150. So when you do the division, well, the negative signs are going to cancel, and having the same digits also helps out as well. So the number of students is 100 students altogether. Well, look at the next one. Similar problem. We have an adult and student rate, and it's set up pretty much the same way. So we have our quantity equation. A plus C equals the total number that showed up, 410. And then the adult tickets were $6. And the student tickets were $4.50. And there was $1,935 taken. And so what do they want to know? They want to know how many adult tickets were sold this time. So what we're going to end up doing is solving for A. So I don't want to cancel out A this time. I want to cancel out C. So I'm going to multiply by negative 4.5. So each number there. So negative 4.5A minus 4.5C equals, this ends up making negative 1,845. So from that point, we add this stuff together, and we end up having to subtract here because they're opposite in sign. You end up with a 1.5a equals, and on this side we have 90. And 1 5/10 does go in there evenly. So make sure you move the decimal over when you do the division. And add that 0 to the 900, and A equals 60. So 60 adults end up showing up. The next type of problem is similar, except it's not admissions, it's coins. And so we're going to have the same sort of thing. A jar of coins contains dimes and quarters, and there's 57 of them. So number of dimes plus the number of quarters equals 57 coins. Now the value, we need to know the value of the dime. It's 10 cents. So 10D plus 25Q equals the total value. Now notice that we're in cents, so we got to change this into cents as well. The value, $9.45, would be 945 pennies. So they want to know, what do they want to know? How many quarters? So let's cancel out dimes. So let's multiply that top equation there by negative 10. Every number there by negative 10 makes negative 10D minus 10Q equals negative 570. Add up these numbers, and this is what we get. 15Q equals 375. If you do that division, divide by 15, and it does go in there evenly. Q is 25. So 25 quarters is the number that we would have. Similar problem here. Jar only contains nickels and dimes this time. Nickels plus dimes. And how many coins are there? It says 59 altogether. Well, the value is $4.70. So 5 cents times the number of nickels, 10 cents times the number of dimes, equals a total of 470 pennies. Again, make sure you change that dollars to pennies if you're in pennies for the value. Now, what are they looking for? How many dimes are in the jar? So we don't want to cancel out D this time. We want to cancel out N. So let's go ahead and multiply the top equation there by negative 5. So each number gets multiplied by negative 5. Negative 5N minus 5D equals, multiplying those two numbers together, we get negative 295. And so we go ahead and add this stuff up. The N's cancel out. We're left with 5D equals 115. And then we go ahead and divide by 5. And D equals, let's see here, we have 35, but I think I made a subtraction error here, so let me check what I ended up doing. So I'm going to borrow all the way back from the 4, change it to a 3. 17 changes to 16, and I see there's my problem. 16 minus 9 makes 75. 175 is the number there. So 5 goes into 175 35 times. So there's my answer. 35 dimes is what we'd end up with. Well, those are the types of problems that you'll see on this week's test. Good luck.